Good morning, class.
Good morning.
How was your night?
That is okay.
It was okay. So I just request all of you to be Patrick. So as Patrick is clearing the board, I'd like to know who is not in and who is around. So let me start by checking the list. Stephen Wandera,
Present.
Mercy, present. Bernard,
Present.
Gladys, Iris. Oh, make sure you tell Iris to see me. So just to remind ourselves, of what we learned last time, that last week, we talked about stress, types of stress, and also the formulas for the stress. Are we together, class? So just remind ourselves, what is stress? We talked about the definition of stress. Stephen?
This is the internal resistance offered by the building material, an external force applied to it.
Yeah, this is the internal resistance that occurs when maybe pushed or pulled, depending with the type of the stress you are working on. Are you working on together, class?
Yes.
We talked about the stress. And Stephen has said that it is the internal resistance. Are you together? So any other person? Okay, types of stress. Mercy? Yes, Bernard?
We have shear stress.
We have the shear stress and the types of stress. We have shear stress. Gladys, what is the shear stress?
The forces acting parallel to the surface.
These are the stress occurring. They occur parallel.
Parallel to the surface.
They occur due to parallel to the surface. Any other person? Yes, Ben? Patrick? Any other type of
Compressive stress.
Huh?
Compressive stress.
Compressive stress. Just from the word to compress. What does it mean to compress? Compressive stress. Remember the stress, the resistance, it occurs into the resistance. What is compressive stress? Stephen?
Yes, these are forces that are ready to squeeze it or push it together.
They occur
Forces pushing together, squeeze it,
due to forces
push together.
pushing together. Remember, to compress is just to put together. You are trying to compress for it to be in one thing or maybe in one situation. Like let's say the spring. When you want to compress it, it will come together. Any other person? Gladys? Any other person?
Tensile stress.
Stress. How does it occur, Patrick?
When the material is being pulled apart.
The materials have been pulled apart. So, just straight to the point today, we want to talk about a new topic that is eccentricity. Mercy, when is today? The date? 11. Good. So today we want to talk about the eccentricity. That is eccentric loading. So just remind ourselves, what is load? What is a load? Patrick, when you say a load,
This is what is the Lord is what is acting on the beam that
Does
is
it-
causing some kind of stress
does it occur only on the beam?
on the structure.
On a structure, that's good. Let's say, for example, right now you are a load. You are a live load. Are we together, class? You are acting on something on the floor. Huh? Because you are trying to actually put some weight on the floor, on the ground. Are we together? So eccentricity, eccentric loading. When you say eccentric, that's from the word esse. Esse means something that is out, something that is away. So for you to not to forget about this thing, there's one eccentricity. You can compare it with concentric. Are we together, class? To say core, which means it is concentric, it is at the center, the centricity. So today we want to talk about this eccentricity, and we want to calculate. And we want to calculate for the rectangular column. Are we together? And I sent a question to the class that is Stephen. I think you shared the question to the class. Must you know the question? Yes. Yeah. Then you can come and draw for us the rectangular.
Ama ni poste.
You're not drawing. Patrick, you're not drawing. You don't have a pen. You can use this. Stevie, you don't have a pen. There is one here. Speed, better because of time. Patrick, you're not drawing. I'll send you out of my class. Let me see. The horizontal digits. That is the distance. Thank you. Clap for Bernard. So that is the question. I hope you have the question with you. So as a class.
Yes.
So anytime, this is a rectangular column. And how does the column, what is the placement? How do we place the columns? Do they act horizontal or vertical? Mercy, the columns. Remember, some people normally confuse between the beam and the column. What is the position? How do we position the beam and how do we position the column? Patrick? For our case, we have the column.
The beam is horizontal.
The beam is horizontal. Good. And the column
The column is vertical.
is vertical. Just a point to know for our case here, Gladys, which one is the beam and which one is the column? Is that this one?
Yes.
And the column?
This one.
The column is this one. Is she correct?
No.
Mercy, come and show us the beam. Because Gladys,
This is the beam,
this is the beam, Gladys.
and at the corner we have a column.
At the corner we have a column. Remember when you are also pronouncing the word beam, your tongue actually goes horizontal. The beam. and the column. Sasa, so don't forget that. Just straight to the point. So anytime you see this question in your exams, remember, you will not only go to the field to work with the engineers or whatever, you are also engineers, but also some of you will one day be teachers. Are you together, class? So straight to the point, when you see this question here, the first key thing you do is to write the parameters. And the parameters are the things you see. Are you together, Bernard?
Yes.
The things you see from the diagram. Sasa, Stephen? So, what can you see from this diagram? You just come here and you write your parameters. Note down your parameters. Stephen? Patrick? What can you see from that diagram?
You can see the eccentricity,
Eccentricity,
the load,
the load,
the x-axis, y-axis.
So, Bernard, this is EY, eccentricity of the y-axis. You can also see?
Yes.
So, just remind ourselves, I just want Patrick to come and write what he has seen, then Stephen, then Gladys, so that you be active.
What else?
Then you can go and write your parameter there.
UI.
Yeah, we have parameters this side. So, you list.
UI is the simplicity.
Stop forgetting.
50 millimeters. EX, that is the eccentricity. The x-axis is
Yeah, that is 60.
60. 69. Yes, we have the x-axis where
Clap for him. Stephen, what can you see from the diagram?
Distance.
Yeah, come and show the distance.
Is this distance here?
Where? Along?
This one.
Uh-huh.
This side.
Remember, it is acting vertically from B to D.
B to D.
Yeah. Yes. Next person. Gladys. So, thank you. So, actually, we had forgot to write the load. This P means the load, that is 500 kilonewton, that is BB. So, straight to the point, let us calculate the area because this is in rectangular form. Are we together, class? So, the first step is to calculate the area of the rectangle. And the formula is, Patrick?
PE. The breadth times the depth.
B times D.
Yes.
And B is massive. B. No, B is the width. 400 times 300. That is
120,000. 120,000.
Yes, 120,000.
You have forgotten 10.
Next is to calculate the direct stress. Are you together, class? And remember, when you are in year 1, you talked about the formula for stress. Direct stress. Direct stress is equals to force divided by the area. But remember, this one is in millimeters. It means that we can also change the force which is in kilonewtons to millimeters. Are we to newtons? Are we together? By multiply by 10 raised to power 3. So our force is
500.
500 divided by area is 120,000. But remember, this one is millimeters squared. So we multiply this one by 10 raised to power 3 Newton. So what do you get?
I'm getting 0.42.
0.42
Yes.
Newton per millimeter squared. Is it true? Not for 4 point something?
4.2.
4 point?
4.2.
4.2? Any question up to that point? From the direct stress, you go straight away to the bending stress. Can I hear it?
Yes.
So bending stress, this is step 3. So how to get the bending stress? You take the load times the eccentricity acting along the x-axis and also along the y-axis. So for y-axis, what you are going to do, you take the load that is from y-axis is equals to the P, which is the load, times the EY, get the bending stress. Are we together, class? So for our case, we have the P. What is the P, Patrick?
It's 500.
500 times the EY, Bernard?
60 millimeter.
60? No.
50 millimeter.
50 millimeters.
But you multiply 10 by you multiply 10 by you change it
Into
to
what do you get there? Mercy? 25. This is P times EX. P is 500 times 10 raised to power 3 times EX. What is EX, Stephen?
60.
60. What do you get as your answer?
Times 10 raised to power 3.
Times 10 raised to power 3. That is good. So, anytime you see this question, the first key thing you do is to write the parameters. Are we together, class? Then you go direct to the area, direct stress, then the bending stress. Are we together? So, just to remind ourselves of what you from the start. What did we say eccentricity? Eccentric loading means eccentricity. What's eccentricity? Which type of load is this? Does it act central or away from the center?
It's a load that acts at the center.
So eccentric loading is a load that acts away from the center. Are we together, class? Bernard, can you just remind us the formula for the direct stress? Direct stress.
It's equal to force over area.
Force
Over area.
all over
Area.
area. So, Mercy, how do you find the area of a rectangle? BD. BD. What is D? What do we mean by D, Patrick?
depth.
Depth. And B? Width. Thank you, Gladys. So, from today henceforth, don't fear this question. Are we together? You may get it somewhere, maybe during the exams, you never know. We can't predict these exams of ours. Are we together, class? Yes. So, just not to leave you reluctant, I want to give you this assignment. You can write this question. Determine the second moment area of
Endelea lakini.
along the x-axis. Classroom, ensure you collect the assignment and bring to my office by 2 p.m.